Today we'll talk about variables, equations, and harmonic mean. A variable is a symbol that represents an unknown number or changing number. Frequently, we use x, y, z to denote variables. Sometimes we also use m, n, p, q, or even Greek letters, alpha, beta, gamma, etc. For example, in this equation, x plus 3 equals 7. The variable x represents the unknown value. This is a linear equation. We can solve the equation, and we know that x equals 4. Why variables are useful? They are helpful to represent unknowns or changing numbers, and they can allow us to express general relationships. For example, relation between height and weight. They can make solving problems more systematic, clear, efficient. Now let's see this simple example. A is 3 years older than twice her brother T. If A is 14, how old is T? We may not need to use variables. This one is simple. A is 3 years older than twice her brother T. So twice her brother T, the age, is going to be 17 minus 3, 14. Okay. Now, what is her brother T's age? That's going to be 14 divided by 2 equals 7. Without using variable, we can find the answer. What if we use the variable? Let's assume T's age is x. Then twice of his age is 2x. Then 3 years older than that is 3 plus 2x. And this equals 17. Subtract 3 from both sides. We get 2x equals 14. If we divide both sides by 2, we get x equals 7. Yeah. Now let's see this more complicated example. What number is tripled when 9 is added to 3/4 of it? This one, without using variable, is not easy to solve. So let's assume this number is n. Now, this number is tripled when 9 is added to 3/4 of n. So this equals 3n, right? So what is 9? 9 is 3 minus 3/4 of n, which is 9 over 4n. So n equals 4. This is the power of using variables. We can solve more complicated problems that we cannot solve without defining variables. Now let's review the general method for solving linear equations. Let's first look at a simple example. 2x plus 3 equals 11. Okay, so how do we solve it? We need to move 3 to the other side. In order to do that, we subtract 3 from both sides. We get 2x equals 8. Then we need to isolate x, so we divide everything by 2. So we get x equals 4. That's the solution. Now let's look at a more complicated example. 2x plus 3 equals 11 minus 3x minus 4 minus x. Okay, for this one, before you move around terms, we need to simplify both sides, okay? So it's 2x plus 3 equals 7 minus 4x. And then we combine terms. We move all the x terms to the left-hand side, move constant terms to the right-hand side, for example. In order to do that, we can add 4x to both sides, and we can subtract 3 from both sides. Then we get 6x equals 4. So the solution is 4 over 6, which is 2 over 3. Now please pause the video and work on the practice problems on page 2. Make sure that you know how to solve linear equations. After you finish, check your answer using the solutions at the back of the book, and then continue watching the video. Given a problem, there are multiple ways to define variables. Some ways may make the calculations a little more complicated. Some other ways will make the calculations less complicated. So what strategies do we have for choosing variables? Let's look at some examples. The sum of 7 consecutive integers is 63. What is the smallest one? Okay, we can denote these numbers as n plus 1, n plus 2, to n plus 6. Then we add everything together and figure out what is n, right? Here n is the smallest number, and this requires some calculation. Alternatively, we can define the middle number to be n, and we have 3 numbers bigger than n and 3 numbers smaller than n. Then if you add these 7 numbers, n is the middle number, so the sum is going to be 7 times n, and this equals 63. Immediately, we can find n equals 9. Then what is the smallest number? It's going to be 9 minus 3 equals 6. See how quick this way it is. Now let's look at page 3 of the textbook, the perimeter problem. The height of a rectangle is 3 centimeters more than twice its length. If the perimeter of the rectangle is 60 centimeters, what is its area? The height is 3 centimeters more than twice its length. Let's assume the length is x. The height is 3 plus 2x. Then the perimeter is x plus 3 plus 2x multiplied by 2, and this equals 60. So 3x plus 3 equals 30. 3x equals 27. X equals 9. Now what is area? So x equals 9. Then 3 plus 2x is going to be 21. So the area equals 9 times 21, 189 centimeters squared. Let's see another example. In an after-school program for juniors and seniors, there is a debate team with an equal number of students from each class on the team. Among the 28 students in the program, 25% of the juniors and 10% of the seniors are on the debate team. How many juniors are in the program? I'm going to define the variables in this way. I'm going to assume on the debate team there are X juniors and X seniors. Now 25% of juniors are on the debate team. So the number of juniors is 4x. 10% of seniors are on the debate team. The number of seniors is 10x. The total number of students is 28. So 4x plus 10x equals 14x equals 28. So x equals 2. Now, how many juniors are in the program? That is 4x, which is 8. The answer is 8. Next, we'll look at average speed problems and harmonic mean. So how do we calculate average speed? Average speed is the total distance traveled divided by the total time taken. So Whenever we need to find average speed, we can use this formula. Now let's look at the examples on page 4. The first one, M jogs 2 miles to the park in 25 minutes, turns around and takes another 55 minutes to walk the same path back to his house. What is his average speed for the round trip? Okay, first we need to figure out what is the total distance traveled. 2 miles going there, 2 miles coming back, so that's 4 miles. How about total time? 25 minutes going there and 55 minutes coming back, that's 80 minutes. Which is 4/3 hours. So what is the average speed? It's going to be total distance divided by total time. So 3 miles per hour. Now let's look at the second example on this page. On the back right, C starts at home and goes up a long hill for 30 minutes at just 6 miles per hour. So how long is that trip? 30 minutes, 6 miles per hour. So 6 times 1/2 is 3 miles. At the top, he turns around and rides home along the same path at a speed of 18 miles per hour. Okay, 3/18 is 1/6. That's 10 minutes. So he spent 30 minutes going up and 10 minutes going down. The total time is 40 minutes, which is 2/3 hour. And the total distance is 3 times 2, 6 miles. So what is average speed? The average speed is going to be 6 divided by 2/3, which is 9 miles per hour. You may notice that 9 is not the same as the averages of 6 and 18, but this is how it works. Qiang drives 50 miles at an average speed of 30 miles per hour. How many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? Now let's see. At the beginning, he drives 15 miles with a speed 30 miles per hour. So the time it takes is 1/2 hour, 30 minutes. Then how many additional miles? Let's say X miles. Will he have to drive at 55 miles per hour? So the second segment of the trip, the time is going to be X divided by 55 hours. Okay, and he wants to have an average 50 miles per hour for the entire trip. Then what is the total distance? That is 15 plus X. What is the total amount of time? That is 1/2 plus X/55. And we want this to be 50. So we got an equation. Now we can multiply both sides by the denominator of the left-hand side. Then we get 15 plus X equals 25 plus 10/11X. We can simplify this equation. We get 1/11X equals 10. So X equals 110. The answer is 110 miles. Then you can go back and check your answer. Okay, if X is 110, then this is 2 hours, right? and this is 110. Total distance is 125. Total time is 2.5 hours. This gives you 50 miles per hour. So correct. Now let's talk about harmonic mean. The harmonic mean of a set of positive numbers is the reciprocal of the arithmetic mean of their reciprocals. So basically, if I have A and B, the reciprocal of A plus reciprocal of B, then takes average of these and then takes the reciprocal. So for two numbers, it simplifies to this and further simplifies to 2AB divided by A plus B. If we have more numbers, for example, n numbers, then it's going to be n divided by the sum of the reciprocals. N divided by 1 over x1 plus 1 over x2 plus until 1 over xn. You see harmonic mean in average speed problems a lot. Let's look at some examples. Page 5, the first example. The water from a swimming pool evaporates at a rate of 6 gallons per hour in the shade and 19 gallons per hour in the sun. For several weeks in August, the amount of water lost to evaporation in the shade equals the amount lost in the sun. What was the average rate of evaporation from the pool? In the shade, the lost rate is 6 gallons per hour. In the sun, it's 19 gallons per hour, much bigger. In August, the amount of water lost in the two different situations is the same, but we don't know how much. We can assume X gallons lost in the shade and also in the sun, X gallons each. To calculate the average rate of evaporation, what do we need? We need the total amount lost divided by the total hours, right? So X gallons was lost in the shade, and the rate is 6 gallons per hour. So the time is X divided by 6. And X gallons lost in the sun, and the rate is 19 gallons per hour. So the number of hours exposed to the sun is X over 19. So this is time. This is also time. Add them together, that's the total amount of time. Then 2x divided by that is going to be the average rate of evaporation. Okay, then what do you see? You have x in numerator and x in denominator, so x can be cancelled. Then this number is 2 over 1 over 6 plus 1 over 19. This is harmonic mean of 6 and 19. So what is this? This is 2 times 6 times 19 divided by 6 plus 19, which is 12 times 20 minus 12, 228, divided by 25, which is 9.12 gallons per hour. Page 5, example 2. Calvin rides his bicycle again up a hill and then back home. On the way up, he averages A miles per hour. On the way home, he averages B miles per hour. What is his average speed for the entire trip in terms of A and B? Again, we do not know how long the trip is each way, right? Let's assume X miles each way. Then the total distance is 2x. The amount of time uphill is x over a. the amount of time downhill is x over b. And total distance divided by total time gives us the average speed. Again, you see that x can be cancelled from both numerator and denominator. So it doesn't matter what x is. And the result is 2 over 1 over a plus 1 over b, which is 2ab divided by a plus b, the harmonic mean of the two speeds, uphill and downhill. Now let's see the example on page 6. What is Alicia's average speed on her walk to school if she walks halfway at 2 miles per hour and runs the rest of the way at 7 miles per hour? Based on our observation from last example, because the two segments have the same length, the average speed is going to be the harmonic mean of the two speeds. So it's going to be 2 over 1 over 2 plus 1 over 7, which is 2 times 2 times 7 divided by 2 plus 7. So it's 28 divided by 9 miles per hour. You can confirm this by assuming that 1/2 of the trip is x miles. Then total trip is 2x miles. The first segment, she spent x over 2 hours. The second segment, x over 7 hours. And this again is 2 over 1 over 2 plus 1 over 7. It's independent of x. Now let's look at some work problems. The first type of work problem involves two workers with different rates. For example, two workers, A and B, can each finish a job by themselves. A can finish in 4 hours. B can finish in 6 hours. How long will it take for them to finish the job if they work together? Okay, A finished in 4 hours, so each hour A finishes 1/4 of the job, and B finishes 1 over 6 part of the job. And if they work together, each hour they can finish this amount of the job. How long will it take them to finish the whole job? That's going to be the whole job divided by 1 over 4 plus 1 over 6, which is 3 over 12 plus 2 over 12. So 12 over 5 hours. Now let's look at example 2 on page 6. The battery in a portable music player is guaranteed to last 17 hours without charging if it is used with headphones, and 3 hours if it is used with speakers. If you use headphones and speakers for equal amounts of time, how many minutes will a fully charged battery last? Now let's see. If we use the headphone option, every hour we are going to use 1 over 17th of the battery. If we use the speakers option, every hour we'll use 1/3 of the battery. Okay, if we use equal amount of time of both options, let's see x hours for each option. Then we'll use x over 17th by using the headphones, and x over 3 portion by using the speakers, and the whole thing is going to be 1. So what is x? X is 1 over 17 plus 1 over 3, right? So therefore, this is 3 times 17 divided by 17 plus 3, 51 divided by 20, which is 2.55 hours. And 2.55 hours is how many minutes? We need to convert it to minutes, right? Yeah. 2.55 multiplied by 60 equals 153 minutes. Now let's see a problem with different starting time. A can paint a house in 5 days, so each day she can accomplish 1/5 of the house. B can paint a house in 3 days, so B can accomplish 1/3 of the house each day. A starts 1 day before Ben, so A starts 1 day and she will paint 1/5 part of the house, and there are 4/5 left. Okay, how many days will it take them to finish painting the house together? If they paint together, the total rate is 1/5 plus 1/3, which is 8/15. So 4/5 portion of the house will take them this amount of time, right? 4/5, 15/8, which is 3/2 days. Adding the first day that Alice painted by herself, that's going to be 1 plus 3/2, which is 2.5 days. So they can finish the house in 2.5 days together. Now let's see the next type of problems. Multiple workers, same rates. A team of 3 workers can paint 5 rooms in 4 hours. What is the rate per worker? So that's going to be the total amount of work divided by the number of workers and then divided by the total amount of time. Now let's see the examples on page 7. It takes 7 minutes for 7 moles to dig 7 holes. What does this mean? So the rate per mole is going to be 7 holes divided by 7 moles times 7 minutes. So 1/7. 1/7 hole per minute. How long will it take 8 moles to dig 8 holes? Now the work is 8 holes. And we have 8 moles. So what is the time needed? Okay, the rate is going to be the same. Multiply the number of moles, multiply the amount of time should equal the amount of work, right? Then clearly you see T should be 7 minutes. Now let's see the second example on this page. 5 moles can dig 4 holes in 3 minutes. Then what is the rate per mole? That is 4 holes divided by 5 moles and 3 minutes, which is 4/15. How many minutes will it take for 9 moles to dig 6 holes? Let's say T minutes. The rate is 4/15. And the number of moles is 9. And we need to dig 6 holes. Then we can solve for T, right? 6 times 15 divided by 4 times 9. Cancel the 3 from 9 and 6 and in 15. And cancel the 2 from 4. We get 5/2, which is 2.5 minutes. Now let's see the example on page 8. 5 hoses can fill 10 small tanks in 80 minutes or 6 large tanks in 90 minutes. What is the least amount of time it will take for 10 hoses to fill 8 small tanks and 8 large tanks? Let's first consider the small tanks. So the rate per hose is going to be 10 small tanks divided by 5 hoses and 80 minutes. Okay, 10 divided by 400, 1/40. Every minute, one hose can fill 1/40 portion of a small tank. We have 10 hoses and we need to fill 8 small tanks. So 1/40 times 10 hoses times T1 equals 8 small tanks. So what is T1? T1 is 8 times 40 divided by 10, which is 32 minutes. Then let's look at the large tanks. So 5 hoses can fill 6 large tanks in 90 minutes. The R is 6 large tanks, 5 hoses, 90 minutes. 6 divided by 90 is 1/15, 1/75. So one hose per minute can fill 1/75 portion of a large tank. Now we have 10 hoses, 8 large tanks. What is the amount of time needed? 1/75 times 10 hoses times T2 equals 8. So what is T2? T2 equals 8 times 75 divided by 10, 60 minutes. Altogether, it's going to be 32 minutes plus 60 minutes equals 92 minutes to complete all the jobs. This is the end of the video. I would like you to work on the practice problems on page 8 about moles digging holes. After you finish, please check your answer using the solutions at the end of the book. The homework for this lesson is page 9, practice problems on variables and equations. Please work on these problems and bring any questions you have to class.